Good morning, and thank you for joining me for the webinar today, Refrigerants for the Future. This is done in conjunction with our partners in the Linde Group, and our subject today is our very low GWP Opteon A2L Refrigerants systems and solutions. You will see through the GoToWebinar tool that there's an opportunity to type in your questions as we go through, so please feel free to do that. At the end of the presentation, I will be joined by my colleague Neil Roberts, who's our technical manager, EMEA, and we will attempt to get through as many of your questions as possible, time permitting. So please feel free to put in your questions as we go through. My name is Mark Hughes. I'm Business Development Manager, EMEA for Chemours Fluorochemicals, and I've been working for many years on our new refrigerants. On my agenda today, I'm going to do a brief introduction just to let you know a little bit about my company. I'm going to talk to you about some of the market drivers which are leading to the need to go to much lower GWP refrigeration. Something about our products and their properties, some real-life case studies, and a little bit about the status of the equipment that's available for the A2Ls, and then how Chemours can support you through our partners, Linde. So a little bit about Chemours, our story. We're quite a young company. We haven't been around for very long. We were a spin-off from DuPont about 5 years ago, and we like to think that we're a different kind of chemistry company. We consist of three main divisions: Chemical Solutions, Titanium Technologies, and Fluoroproducts, which our fluorochemicals and our refrigerants forms part of. So we're a market leader in the manufacturing of fluoroproducts. Our purpose is to create a colourful, capable and cleaner world through the power of chemistry. So we continue to innovate, and the range of Opteon refrigerants that we're going to talk about today is one of our latest developments that we've come through. We're called Chemours, chemistry from chem, and ours to create that clear connection with our customers. I hope that you find today's presentation interesting. So one of the messages from this presentation today is to be prepared, because over the next few years, most new refrigeration systems installed in the EU will have a refrigerant that is either explosive, toxic, or flammable to some degree. And the products I'm talking about today are of a low flammable nature, but they fit into the last category. One of the biggest market drivers we have, of course, is the F-gas regulation. We're all clear on the service ban which has been in place all of this year, which banned products like 404A with very high GWPs for service. In new equipment, you can see there a list of the various bans which are either in place or coming in the very near future. And therefore, this does mean that there is a requirement to go to lower GWP. This is the familiar F-gas phase down chart, and you can see as we move through the F-gas that we see an increasing reduction in the amount of quota available. And one of the key ones is that next year there will be a large cut in the amount of CO2 equivalent that's available to the industry. You can also show this in a different way, and this is the first time that I start to demonstrate the Opteon refrigerant portfolio. You can see there on the left-hand side, there is the global warming potential of the various refrigerants. On the right-hand side, you can see the dates when we have to achieve an average GWP around the number shown to be able to remain within the cap that the F-gas puts us under. So you can see that 404A as a high GWP refrigerant is already basically out of the picture. And as we go down, we go to gradually lower and lower GWPs. Products like XP40, 449A, you will already be familiar with. This is one of our retrofit products, but you can see that the GWP is in the mid-range. Familiar products like 134A are also in the mid-range. And we go down, you can see XP10, 513A, which has a 134A replacement. This starts to take us into the lower GWP range. As we get to next year, we need to have an average GWP of about 900. And it's clear that we're actually not at that range, which is likely to cause some tension in the coming years. Eventually, as we get to 2030, we need to have an average of around 400. So that's the sort of area that we're looking for products to be at or below. And there you can see a range of the products that we have, which some of which I'll be talking about today. So one of the key market drivers that we see is product availability and price. And in the late 2017 and 2018, when we saw the last big cut in quota, we saw what happened in terms of pricing. The small graph at the bottom shows the evolution of pricing of HFCs in the EU when that occurred. Now things have settled down a little bit since then, and but that is for a number of different reasons, which I'll mention later. As I've already said, the Virgin 404A ban started this year. Reclaimed 404A can be used, but the stocks which are out there from the different providers, such as Linde, can be used, but that stock is required for the whole of the EU, to service the whole of the EU. And the amount of retrofit that is going on has decreased to some extent because of the reduced cost of the high GWP refrigerants and their high availability. But the replenish of that reclaimed stock is required to be able to service systems going all the way to 2030. The reason that reclaim is required is that many R404A systems, particularly the smaller ones, have not yet been dealt with. And next month, what comes, as I said, in 2021, we see the next major quota cut. For manufacturers, incumbents like Chemours, it results in a more than 40% cut in the amount of refrigerant that we can place on the market based on the CO2 equivalent. Another market driver, of course, is the actual cost of what we're doing. The phase down that you see will eventually prevent the installation of high GWP refrigerants for a number of reasons. And end users have to consider availability and cost of new technology. And this is the first time I mention it today, but you'll see this an awful lot during the presentation. Energy efficiency. Energy efficiency is a key decision factor. It should not all be put on the basis of GWP. To help industry move to these low GWP refrigerants, we need to have the ease of design, installation and maintenance wherever possible, because we tend to lack trained contractors in our industry. The example I'm going to look at more closely today is commercial refrigeration. Of course, any solution that we come up with has to be sustainable in the longer term, and that's under F-gas or the Kigali, which goes on past 2030. But actually, when you're looking at very low GWP products, once you get below about 300, the climate impact is all about energy performance. So 300, as we go into the future, is really the sort of key area that we're looking at. If we're around that or lower, then we're in good shape. But we need to keep an eye on energy performance. And of course, any refrigerant that we use in the future, we've already said that most of the refrigerants that are going to be used in the future will have some form of hazard associated with them. But we need to make sure that we have the lowest risk possible with all the products that we're using, and the ones we're talking about today are proven safe to use. We can see that we have the safe charge sizes, and I'll show you basically how that is calculated. And larger charge sizes are possible with appropriate risk assessment. So this is a guide that we have. I'm not going to go into this in great detail, but just to show you that we've got, as I said before, the XP products, which were the retrofit products with their GWPs. And then today, in detail, I'm going to go into these two products here, XL40 and XL20, which are HFO blends with these very low GWPs below 300. And in the case of XL20, we're below 150, which is a key target that has been set by the EU F-gas regulations. To replace 410A, we have two products here, and the key one that we are really working with mostly and is being adopted in a lot of chillers and etc. is XL41 R454B. In terms of 134A, we have a couple of replacements. With the A1 replacement is 5133A, which is already being used, XP10 in the marketplace, and then pure 1234YF is the other option that we can use at very low GWP. Not going to go into R22, but today, if there's R22 systems out there, we still have products which can either be fully replaced, like with XP40 and XL20. When you've got in XL20, it would be new equipment. And in the case of doing retrofits with an existing HFC type product, then MO99 R438A is still available and is below the 2500, but rather high to be possible to be a product to use in the future. And then in the centrifugal chiller side of things, on the low pressure fluids, we have products such as Opteon MZ and XP30, which have very low GWPs. And in the case of MZ, are in fact A1 fluids as well. So we have a whole range of products here that we can use. But as I said, today I'm going to focus on refrigeration applications which used these two key products, which are the R454C Opteon XL20 with a GWP of less than 150, and 454A, which is another product which can be used where products above 150 are available can in fact be used. So there are quite a few low GWP technologies around, and I'm sure you'll already be familiar with them in many of the locations that you're at today from that point of view. But how do you choose which one you should use? So I'm listing here, it's not an exhaustive list, but these are the sort of major ones that are really being considered specifically for commercial refrigeration from that point of view. So our baseline is really the mid-range GWP. This is the 449A, the XP40 type product, and we use it as a baseline today. It's being used up until now for new systems to replace 404A systems, and also for retrofit. The self-contained plug-in, so-called integrals, either water-cooled or air-cooled systems. Secondary loop systems, such as R290, so propane glycol systems from that point of view, or even 134A CO2. The products that fall into the Opteon XL range are these HFO A2L systems with GWP below 250. And then finally, direct CO2, which is the transcritical CO2 R744 booster systems. So we went out to find some independent consultancy to help us look at cost in terms of 10-year life cycle cost, energy efficiency, and then also looking at total emissions, so which points to the sustainability. And there's a company that we work with called Wave in the UK. They work outside of the UK as well. They're involved with many retailers, working with a variety of technologies. such as Aldi. So we went to them and we asked them to put together a model which based on their actual experience with the different technologies, so we can do an apples with apples comparison. So we chose 3 locations, a moderate climate, which would be in the UK, which was chosen to be Leicester in the UK, Sevilla in Spain as a hot climate, and then as a cool climate, Helsinki in Finland. We chose a standard supermarket layout around 2,000 square meters, and also a small supermarket, which is the 300 to 500 square meters, a sort of convenience store size application. So when you do a comparison of cost in terms of the running cost, and at this stage I've just used the standard supermarket, the small supermarket data looks very, very similar in fact, but for comparative purposes, so that you can see, we can show on here the relative cost of the different technologies based on the dark blue element in the graph, which is the capex, so the initial cost of purchase, the maintenance over a 10-year life cycle, and the largest part of the bar is at the top there, which is the energy expenditure, which is the amount of energy used to drive the system over the 10 years. And you can see that that energy that's used is by far the largest contributor to the amount of cost for putting in a specific system. So you can see there, if you do a comparison between the different technologies using the process that WAVE, the consultants, went through, you can see that air-cooled and water-cooled integrals, particularly with using propane, are actually the lowest capex technology, but they're the highest in terms of their 10-year life cycle cost because of the amount of energy that they consume. Transcritical CO2 systems are quite costly compared to the Opteon XP40 baseline. The secondary loop technologies also are a higher cost in terms of their both capital and operating costs compared to the XP40 baseline, up to 22% higher. But if you see there at the very left of the graph, you'll see the XL refrigerants with life cycle costs some 16 to 22% lower than transcritical CO2, or indeed the water-cooled integral options. So you can see when you're looking at cost, the XL refrigerants make a lot of sense. So what about the environment? We use the total equivalent warming index to work out the effect on the environment of the amount of energy that we're using within the system, and also the direct emissions, which is the leakage from the system. You'll see in there that we've chosen specific leak rates. A leak rate of 5% for the XL products, that might seem quite low relative to how industry has been performing up until now, but we believe that that is the standard which should be, by any responsible retailer, for instance, should be heading for those numbers or below. Electricity generation, obviously, that does vary depending on where you are, the amount of embedded CO2 in there. But of course, all electricity costs money wherever you are. So if you're not talking just about the environment, you're also talking about the cost to the end user, which is an important factor. But we've taken all that into account in our TUI calculations. If you look in the if you then start to look at them about emissions and about what's happening in the environment, let's face it, F-gas is designed to reduce the impact of F-gases on the environment. And this is how it looks at 10-year direct emissions and 10-year indirect emissions. So the indirect emissions, as I've said, in most cases is the energy that's used to operate the system. and the direct emissions are the leakages. And you can see on a graph like this, 404A absolutely stands out because in terms of its direct emissions, it's very much out of the picture, and the reasons that it's really its use has completely gone almost completely now. On this end, you'll see that the XL products, they have the best profile as far as environmental performance. Air-cooled and water-cooled integrals have the worst emissions over a 10-year period. Transcritical CO2 systems have higher emissions than the Opteon XL options, and indeed secondary loop technologies do not figure too well when you do a side-by-side comparisons. And the XL refrigerants have by far the lowest emissions compared to the other low GWP options which are on offer. So, as I said before, we picked an annual loss rate of 5%. But what happened if the loss rate of those HFO blends was higher than 5%? Well, even at a 15% leak rate, we are still showing an advantage over the other very low GWP technologies, as you will see on this graph. So this basically maps out the value for money for the various technologies. Up the side, you can see the emissions in terms of the 10-year emissions per kilowatt of cooling. On the bottom, you see the life cycle cost. So anything in the top right corner is less favorable from a value for money point of view, and also in a sustainability or emissions point of view. In the bottom left corner, we see the more favorable. And you will see that the XL products, the XL20 and the XL40, fit into the bottom left corner. The other options are all around that you can see. You can see the R290 glycol, the CO2 transcritical option. Up here in the top left corner, you see 404A. You can see why that is an outlier now. So whether you're in the climate of Leicester in the UK, in Seville in Spain, and indeed even in the more passive climate of Finland, you can see advantages in using the lower GWP XL products. The air-cooled and water-cooled integrals, as we've said before, have the highest emissions and the highest 10-year life cycle cost. So even though they might seem like a good idea from a CapEx point of view because they're relatively cheap to buy, in terms of their performance in the longer term, they are not the right option to go with for every system. The XL refrigerants have the largest emissions reductions by 14 to 20% and the lowest 10-year life cycle cost of 8 to 15%. So, you know, obviously CO2 has gained a lot of ground, and you know, we are basically looking at trying to do apples for apples comparisons. But what we've been really doing in our experimentation is to look at which refrigeration technology delivers the best balance of emissions against life cycle cost. So, you know, there's a lot of CO2 out there. A lot of the big retailers have already gone to CO2, and so, you know, we might ask ourselves, well, you know, if products like the XL products are so good, why has the industry moved in that direction? Well, what was, you know, when CO2 started to be developed, you know, on a commercial basis, you know, over the last 5 to 10 years, you know, when we were looking at emissions, the options that we had were fairly limited. So if you look at 404A and you look at emissions, and you can see on the graph there, you know, wherever you are in Europe, you can see that you do get a decrease by going to retrofitting to the XP40 like 449A, and that's obviously happening and been happening in the larger supermarkets. over time in the retrofit programs. And then obviously to take that next step, there was the installation of transcritical CO2 flash gas bypass systems around the place. And you can see there then, you know, you're losing the direct emissions element of that. So that initially showed CO2 to be, you know, a very good choice for moving away from 404A. But of course, then if you take into account life cycle cost, the CO2 is a more expensive option from that point of view, with actually 449A being one of the cheapest options. But of course, it's not sustainable in the longer term, being a medium GWP product. So we've talked to a lot of retailers. You'll see from the case studies that I'll show later on that a number of retailers have compared their decision criteria against the technologies that we've been offering. And the key elements for them and for other end users in cooling is to match the cooling performance of the products that they're using today, match or indeed exceed energy performance where possible, match uptime. So we need reliable technologies that don't fall over when we get a few hot days in the year. Match or improve total cost of ownership, and ideally match the ease of installation and maintenance. So is there a better option than R744, than CO2? And the answer is that we believe that there are better options, depending on the application, particularly at the smaller end of the market, the smaller end of the commercial applications. So the total emissions with Opteon XL refrigerants are, you know, in a hot climate like Severe, it's some 18 to 20% lower than CO2 in those things. We all know that CO2 struggles in hotter climates, but even in the UK, we see 15 to 17% lower emissions and 6 to 8% lower in Finland, which we would expect to be the kindest to technologies like CO2. In terms of life cycle cost, we see 17 to 18% lower in Seville, and 14% lower in the UK, and even in Finland, 8 to 9% lower. So we often say here, people say, well, you know, CO2, there's lots of ways of making it more efficient. We can add different components onto that. The technology has developed over the years to basically try and compensate for the issue that CO2 has in terms of efficiency. And these are some of the different technologies that have been developed. I'm not going to go into the details of those are for a more highly technical presentation. So if we compare in each of the different climate situations, the optimum CO2 technology that can be used in that location with the XL refrigerant technology, we can do a fair comparison for each of those locations. You can see on this graph that in each case, the XL products do deliver the best total emissions and the lowest life cycle cost when you compare against CO2. Up to 20% reduction in Seville, 18% reduction in Leicester, and 12% reduction in Helsinki. You can see in each case we've chosen the best, the best CO2 technology to cope with the climate in that specific situation. You know, ejector technology in Seville, parallel compression in Leicester, and internal heat exchange in Finland. The XL refrigerant technologies deliver the lowest emissions at significantly lower life cycle cost than the 744 technologies. So we see up to an 18% reduction in Seville, 14% reduction in Leicester, and even in Helsinki up to 9%. So in summary on this piece, if you're looking for a very low GWP alternative to 404A for a new system that matches cooling performance, exceeds energy performance, matches system uptime, matches total cost of ownership, ease of installation and maintenance, and if that wasn't enough, reduces CO2 emissions by up to 20% with the lowest life cycle cost, why would you use anything else? Well, a number of our end user partners that we've been working with have basically made that decision to move in that way. This is a convenience store with Central England Co-op. So this is they run a chain of smaller end stores. In this case, an A2L ready pack was installed over a year ago. This was one of the first stores to use the XL20, the R454C, with a GWP of less than 150. You can clearly see all of the benefits there on the list. One of the things I'd just highlight is that using their own internal energy monitoring of a store based on 448A versus the 454C, they saw energy savings up to 11%. On top of that, they experience lower capital, maintenance cost, and total emissions compared to some of the technologies that they had considered to use, which were CO2, propane glycol water loop, or propane integral systems. So on the basis of the trial that they did, which is now a running store, they are now rolling out this technology for all of their future stores and all of their refits of existing stores. One of our longest partners has been Asda in the UK. They run hypermarkets, and we don't see the XL products being obviously for large centralized systems. Asda, though, has a modular approach to their refrigeration, and therefore they can use the smaller charge sizes that are allowed for the XL products. And in this case, they decided to use 454A, and they've been extremely pleased with the performance of the product, and have seen around 5% improvement of energy performance compared to products like 448A, which they use as the main part of their estate. And indeed, they are now moving forward with a vigorous and ambitious store replacement refurbishment program through next year and beyond, to move away from the medium GWP of 448 to the low GWP, in this case of 454A, with a GWP below 250. Outside of the UK, I mean, the UK has always been a fairly, an area for innovation, whether it be CO2, but now also with the XL products. But in this case, we are seeing developments in other countries, and I've pointed out here, this is a Spa in Barcelona. Again, a relatively small store with 600 square meters. And in this case, it's a small pack, A2L pack, that's been developed on 454C XL20. And this Spa chain has just opened its second store and has an ambitious program to introduce this technology throughout the spas in Spain. Spain has a HFC tax. This tends to push things a little bit faster there, but the F-gas phase down, as far as it affects the rest of Europe, will have a similar impact on the cost of refrigerants as we go forward. So moving outside of retail refrigeration into more industrial or commercial refrigeration in terms of storage, cold storage. In this case, in France, we see a large cold store here. This is low temperature, -25. and the use of multiple condensing units running with 454C, that's the XL20, to maintain produce within this cold store. The cold store area is very much dominated by ammonia, and CO2 has started to penetrate into that area. But for the smaller end of that market, we believe that the XL products are a very good option to be able to meet the needs of those who are unable to use ammonia because of their location or the inexperience of contractors, potentially maintenance issues from that point of view, and also the inefficiency of CO2 in such systems. And in this case, we can see here, heat recovery is installed. It is possible with the XL products. It's not just a property of CO2 systems that you can do heat recovery with products like XL20. This is one of our longest cold storage case studies. This has been running for more than 3 years at Parkcake Bakeries in the UK, in Oldham, with XL40. Again, pretty standard setup with condensing units, and I say running without issues for more than 3 years. But at the smaller end of the market as well, we are seeing some take up now. We have a commercial offering from a company called Master, a small condensing unit here. The charge size here is just over 1 kilo of R454C XL20, and this is used to cool the canteen facility for the staff at Riverford Organics. The interesting thing about this is that this company, as a provider of organic food, was very strongly influenced by the environmental credentials based on the emissions that come from using a product like XL20 compared to something like a CO2, a condensing unit. And again, I think the message that comes out of this is that the energy performance and how that converts into emissions is a very important factor to look at, not just GWP. Now, things are starting to develop. You might be out there, your clients may be out there saying, I would like to use and have a go at using one of these A2L products, but can I get the equipment that I need to be able to have that installed in my application? Now, the good news is that we are seeing every day. It's difficult to keep up with it. I've just given a sort of a summary of some of the developments and some of the announcements that have been made. Basically all of the major component and compressor OEMs now have product available for the XL range. So not everything is necessarily in the selection software yet, but it's coming very, very soon. So most of the applications that you would need product equipment for, if it's not available now, it will be available through the wholesalers very, very, very soon. And what does that show? What it shows a recognition of the industry that there is an area where products such as the Opteon XL products are required and needed to help us get through the next elements of the F-gas phase down. So, how can Chemours support you in this? Through our partners, Linde? Well, as I said, I've spent a lot of time today talking about the products and the availability. But remember, they're not exactly like the product that they replace. The A2L products do have limitations on the charge size that can be used. So that necessarily limits some of the applications to some of the smaller end of the market. But you can easily calculate how much product you're able to use in a given situation using the guidance in EN 378, and we've actually put together a tool which allows you based on the application and the size of the room that you're cooling, or the cold store, whatever, to calculate what the maximum charge size is and what sort of mitigation that you need to get over the low flammability characteristics of the product. Again, some of the information I've provided today, I mean, I've obviously gone through it fairly quickly, but we have infographics available, which basically shows, is there, which can show end users in an easy to digest way how A2Ls can help them in terms of life cycle cost and emissions. And these are all available through our website or by registering at opteon.com. I haven't spoken in a lot of detail today about the flammability properties of the A2Ls, this low flammability, but to help contractors, installers, end users and consultants understand what the differences between A2Ls and A3s in terms of flammability, we've put together a helpful video from an industry expert who works on flammability, which gives a very clear picture of the relative risk, if you like, with using A2Ls compared to A3s. And finally, we're working diligently in terms of all of these, whenever you're using a product with a hazard like flammability, even if it's a low flammability, you need to conduct your own risk assessment. And we're helping put together such risk assessment guidance on a case-by-case basis as our partners and their customers and the end users start to introduce these technologies, which will be necessary over the coming years. So this is my final slide. This is my my summary of the of today's presentation. I'd like to thank you for your attention, and I'm going to open I'm going to open up to questions. So the first question I've got is, do we get the presentation after the webinar? Yes, I will make the presentation, a PDF of the presentation, available through it will be available through this tool, so that this is being recorded, and therefore you'll be able to play it back at your leisure at any time, if you've already obviously registered, as you have done for this webinar. Just looking for any further. Just looking to see if any more questions there. Is anybody typing away? Oh, so this question is, what is the refrigerant choice for the future for large size air conditioning systems? Yeah, I haven't, as I said, I haven't spent a lot of time on air conditioning today. I mean, that's basically another presentation in itself. I mentioned products like the XL41 with the GWP just over 400. That's very much being adopted, as a lower GWP option for chillers. So obviously, in the chiller side of air conditioning, that's definitely an option. And indeed, products like the Opteon XP30 and the Opteon MZ, which can be used in centrifugal chillers, of course, those also, they have GWPs. Very, very low GWPs, and in the case of the MZ, they're actually A1 refrigerants. They can be they can be very much used for air conditioning type applications. Distributed air conditioning like VRF, VRV, that's a much more difficult situation. It's being attempted. That the standards are helping to get R32 introduced there, and if R32 can be used there, then indeed products like the XL41 with its lower GWP could be used as well. But that's very much an area under development, and I say keep if you subscribe to our newsletters, you'll get information on that as things go forward. So always a good question I get: what are the price of XL compared with the 449A? Our strategy is to keep the XL products either at the same as or lower than products like 449A. And the reason for that is obviously we want to see long-term stability of these products. And the key thing is the prices of products like 449A will inevitably rise because they're medium GWP. So the CO2 that's embedded in them effectively causes them to increase over time. The XL products having, very low GWPs, they don't have that embedded CO2. So there's not the same pressure to increase them as the cost of CO2 equivalents increases. So I hope that answers the question. Basically, we should see very stable XL pricing over the next years compared to the prices of the higher GWP refrigerants. So about A2L, which is the charge limit for a unit? Well, on that one, I can then point you to our charge calculator. If you go into there, as long as it's one of the products that we're offering, you can specifically look in and find out the charge size for a unit. For a hermetically sealed unit, this is also determined by one of the equipment standards, IEC 60335-2-89, which puts a maximum of 1.2 kilos on the equipment. If you go above that, if you want to go above that, then you go into the EN378 and you can use the charge calculator. Very good question, and thank you for asking. The next question is: are these new refrigerants usable in current equipment, or does it need to be upgraded? The latter is the case. These cannot be retrofitted into existing equipment. It is possible to upgrade equipment, but it needs to be done so that, for instance, the compressor needs to be A2L ready, and the other components, which are all available now, would need to be switched out. So it would all need to be checked against the equipment manufacturers' standards from that point of view. So the easiest way or the necessary way, and in most cases what we're seeing is that this is new equipment that's being installed, where old equipment which has come to the end of its life, or for a completely new installation, the A2L products are being used in those situations.
Mark, is it also worth mentioning at this point that one of the reasons you can't or you shouldn't retrofit is that often with the A2Ls, the PED requirements, the Pressure Equipment Directive is going to change the rating of the equipment, and this is something that it's going to happen with all the low GWP replacements which are coming along. PED requirements are going to be higher, so it's not something you can escape by using, say, CO2. You're in the same situation there, or even hydrocarbons. So it is something which is going to come along, and it is a big factor when you're looking at retrofitting existing equipment as well.
Yeah, thanks, Neil. That's a very good point. And again, I talked about things like risk assessments and the rest of it. As we move into this age of having refrigerants which are not the same as the ones we've had in the past, then things like PD, Pressure Equipment Directive, will be a key area where contractors are going to need to have, going to need to have the knowledge. And as I say, we're working with trade associations, trade bodies, the various institutes, and to ensure that the guidance on PED is out there. But the equipment manufacturers themselves should be able to give guidance also as far as that's concerned. And all of the equipment that's being manufactured pressure equipment will meet the PED requirements of that specific fluid from that point of view. But it's a good one to pick up, Neil. Thank you. I don't see many other questions coming in, but if you have other questions following today's presentation, you can see my email address on there, and I think it was on the original invite as well. Feel free to send your questions through. Please opt in to get emails from Chemours, and you will get our very latest information, campaigns, etc. As we move forward. And I appreciate your attention today, and I wish you a good rest of the day. Thank you very much for attending today. Bye-bye.